我是首先会有新闻的有然后到那个不知道什么，
因为我英文蛮好的，
我知道是
你英文
这个口语其实蛮好。
没有，
然后而且它是会小过这个题目。
你说说看，
还有这个我也讲，但是我可以念给你。
等一下，
然后我把你
这样子，我不知道，我不知道。
然后你一定打不过长度。
这样子我还能定一个新的，我要定一个新的一个新的。
我找来问，
已经有个 A 这样子。
不过你还要有speak English，
只是有点哇，但是讲是讲
什么？
这个是
还这样子，
没有，先教来。
还这样。
英文问题没关系，我这个去找类似。
他我这个 A
列了，他之前用过，用他用上
所有 A 3里面，但是我的线里面只有 A 1跟 A 2个。
对，你首先你得在这里部署。接下来你要找接下来的话，你要找接下来的 A。放下来也讲到一个地方，用别人之前的，你看到没？
我还是一。
两转，就是我只需要点13109，然后跟这个同对了。你要找 A2的话，你就带给加1这个点，所以如果你的方法中是自己找是的话，这是你就是你因为你要找 A 的话，所以现在 N 的1，所以 A 2的1。
日本他们两个相似的前提是内角三个角一样，然后边的话是比例一样，
没有，它因为说 in this case 不是一个不懂 A， 如果你想说是一个对它讲相的，你不懂那了解这样我们知道对角的说法大多这个不伤我们两这边那个号码的人 A3。然后我们是B3就拿 B2
B3。
就讲你的，我现在没有上题吧？没上我要，B3就要让他的，你就你
你要找 A，应该先对比先。
可是你他是同学。
没有的话，你就在哪？你就在一直回到两个一起，但是回过就是这三个错，然后这个是像 B 是几度啊？是像 B 几度啊？
对的，如果是 in this case 的话，然后不是 in this case， 我一定要讲1:3，因为
1:3 37度啊，这里面，是
哎。
等于
这个差不多是他们弄在哪说1:3，有一个喜欢叫7度，也会说他讲这个小狗40的位置，这个号码。我有在楼下看大点，这个我在上，我在上看到这个质量这个，所以我还有前面还有有一个这个片，所以这个需要我们然后还有第三的片，然后差不多是这个，然后我去多题啊，我就找那个在不管是在当时会要想这个，
他做哪里？
对，像我的 A3是哪个 ？A3要补习那个，
因为假设你的 A3 你算上你 A2 加 B2 取上，不是一个号，这样你就把我删除这个。你有什么是错的？因为这里有对。
变回来了。
因为我不是这个我的 A3。
Hello testing。OK，说适应开课前论文是很重要的，很重要。MA 的方向在哪里
？MA 的不是从这个，这个是有2个
direction， 是 direction。有没有人读到 loss 呀？ 啊？没有方向。
可以用在什么题？
哦，OK，还有呢
我觉得老师讲不懂的有没有？
？OK，可以，OK，，OK，还有呢？还有人吗？
你的上面可能这样子，他们这小时有应该会有。
还有人其他人有方向吗？有人有方向了吗？先讲。
哪个小时我在跟给的？
美丽啊，发开了4点。
方向的话说一说方向。
这里不管就是他，哪一个我不确定。
有方向吗？这里？没，方向在哪里？他在做什么吗？他在做什么？
有8个，知道这个。
说说看，说说看，
我看
你跟他确定什么哈？
看
讲讲哈，先讲啊，如果你们是没有走，实际用途是没有 ，OK，实际用途是没有啊，但是呢，你的那个逻辑啊，肯定会用到。OK，你不会看到可能 epsilon delta 在你在算钱的时候呢，你也不会再看到你做生意的时候看 epsilon delta 的东西了。但是呢，epsilon delta 做了什么事情呢？你要找 epsilon 钱，一定要先找同点。比如说你要找钱的时候，你肯定要做空间嘛，所以有一个因果在那里，所以要怎么从因去到果，这就是我们 analysis 要做的事情，就是我给你一个条件，你可以满足这个条件吗？为了要满足这个条件，你要做什么事情可以满足这个条件，对吗？你明白吗？这就是这一个课的主要的核心。如果对于不是要走平衡式的来说，就是说我给你一个条件，我条件一直换 ，OK，我的目标一直换，OK，从不同的条件我可以去到同一个目标吗？还是我从不同的条件我可以去到不同的目标？OK，这就是这个课的核心。OK，但是如果是说要走数学系的话，OK，这个课更是重要。OK，这个是一个基础的证明的课，基础的 proof 课。OK，如果你 proof 不能够写完整，基本的 proof 不能够写完整，那你以后去证明更难的理论的时候，你说服不了人。你说服不了人，就算你的 idea 多好多正确的话，没有人会拿你的想法的，你就跟你一起埋葬进去土里。如果烧的话，可能丢进海里。所以另外一个方面就是你要学会怎么去说服人。这个课怎么说服人？你只能讲理罢了。OK，当然这个不 apply for 男女之情啊。OK，你越讲理，可能人家也不理你。但是就是说你怎么去正常跟人家交涉啊，什么这样？OK，你要用 logic，用理论，用理由。OK，要理由人家听，周末我要听你的啊，因为什么对呀，对吗？可以
OK，
get 到。而且在我这个课啦，我会比较 focus on 一些比较 constructive 的东西，就是我们要去创造一些东西，给你一个句子，OK，什么 sequence 啊，什么 subsequence，但是 sequence 跟 subsequence 里面，你怎么找出一个有用的数列来？OK，你要怎么去挖出这个数列出来？OK，而不是我们只是去证明它的里面它 converge 吗？它的里面是什么？我们要看的是它里面是怎么去 converge。这样子讲啊，一个 rule 你抓住 ，OK，我让你抓一个方向，让你抓一把木，什么木？OK，这个木就是如果你开始想象不到我在讲什么的时候，你要求我画出来，对吧？因为我通常在讲的时候，通常是有一个画面感在我脑， 有时候我没有空把它画出来，所以我不小心 skip 了，或者我感觉那个画面很清晰，已经在了，所以我忘记画出来。所以如果你觉得很空很干，你的老师可以画出来吗 ？OK， 然后我就给 example 啊等等 ，OK 吗？这样 ，OK。OK 啊，所以为了体现这个principle，Hello，哎，不是塞车吗？啊，汽车。OK，所以为了体现这个 example，不是我们花一点时间来做这个 tutorial，我们花一点时间来做这个 tutorial。OK，真的一点，然后只给你5分钟吧。我们分一下组员，好不好？分一下组员。我们分一下组员做这4题。OK，so 我看一下啊。综艺跟Jack 一起了，and then 我们一 pair Lo Hao 和 Ivan 一 pair，
忘记了。
Ethan 跟那个志英一 pair，OK，and then 那个这么名字全部忘了Larry 跟金正一 pair，and then 若兰可以坐来前面吗？我们来一 pair 一 pair 讨论功课，然后太多 pair，Sydney 跟洛然一 pair 哈，and then 欢野跟汉伟一 pair，OK， 所以1、2、3、4、5、6，OK 6个，所以我们有 pigeonhole principle 嘛，所以有2题，一题一定要有2个人做至少，OK， so Jack 做，来给 Jack 要不要提高难度一点？OK，Jack 做第3题 ，OK，Jack 做第3题。然后罗浩来做多一点，做第1题，好不好 ？OK， 一题，放大一点，可以放大一点。思莹跟伊真，你们要抽象一点，还是要具体一点的？没有，你给我一个，我就选一个给你。
他俩都讲一下嘛，我们
讲吗？没有，你要抽象的题目还是？
抽象是哪个题
啊？没有，不要，你只可以选抽象或那个吧。
一个用的。
你要抽象还是比较 practical 一点？选一个。practical 一点 ，OK， 做第1题，跟罗浩一起。
那抽象呢？
抽象其他。不可以选了，就不可以选了，不要认签。反正你有机会的，全部都是你做的，不要怕。只是现在我们讨论罢了。啊？
一起做还是分？
你们要一起也可以，分开也可以，反正你们都是选一样的了。OK， 什么？你跟我一组。我跟全部人一组。OK， Larry 跟医生做第4题。
跟我看老师就可以了。
什么？
老师跟我一组啊。
可以，等一下我们一起讨论，不用怕，只要你们 try 一下。说若兰和Sydney， 你们要抽象一点还是 practical 一点的？选一个，快点，赶紧。来，抽象一点啊 ，OK， 来做第2题，做第2题啊。Ethan，不了，那个汉伟 and 宽也，我们 try 也做第2 ，OK， 做第2。所以我们现在分组的是小童和那个尚儿一组讨论做第3题，做第3题啊 ，OK， 做第3题 ，OK， 我现在给你们 about 8分钟啊，8分钟讨论，去挖 definition 出来，去讨论怎么去找 ，OK。结局不重要，但是过程很重要啊，过程很重要，因为我已经有答案了，所以我要你们讨论这个过程。Actually 有 PDF file 啊，在 Moodle 啊 ，PDF file on Moodle，there's a PDF file on Moodle。找了不到？为什么？没有完没？不可能啊，我不是在上着玩咩？ 这么奇怪？可是你们连那个 staff
我是给他上个语嘛，
staff 码你们不知道没有？
要知道，知道。我们知道 staff 有没有 staff
听不到，我这个在有着我。我接不到不紧啊 ，OK， 先暂时先看这个啦，先看这个啦。OK 啊，11点20分啊，我们讨论11点20分讨论啊。如果谁做完了做其他的，
电话领导，你跟他讲好，我自己好像他讲好这样子来。
谁？
啊，他在 IT 村，然后有他讲他给 IT 对了。
Okay, just find any group and join them.
真的吧？你看好，我给你A B C D 一样的。哦，可以，没问题，没问题。呀，我们1、2、3，几个动作呀？
我做一个。
然后，不要错，到不要错，跟我都是一样。这样子。
有差别。
Tapi kalau order tu saya minta lupa ke
不是。
对两个人。对，基本上都是那个差，反正也就差不多少。
就
关系，想在读书了。我说你们。比较方便。
可以那样 proof on definition。你可以用 every two to understand 这个 set， but proof 是什么呀？你可以用 any mean to understand 这些。Yes。So，这些题目哦，不要问方法，问定义。这样说，你可以用任何方法去 tag 啊，但是你一定要怎么达到定义 ？Axiom definition。OK， 任何方法你学过的、你想到的、你想象出来都可以用，对吧？一定要用定义去证明，对吗？可以 try 就 try 罢了，我让你享受的是这个过程 ，OK。
享受有这个过程，就享受了，但是受不了。一直是想，他不是想。受。
我真受不了。
哦。
有一点。
好像不是。说说你不爱笑，你这天生不爱笑吗？
真是受不了。真受不了。喂？
这个是理解。
连第一题的人如果找到答案不止 try to prove 它 on definition。OK， 找到了 prove 一下，证明。对。
No Wi-Fi。Lecture 7。
说你2004开始出生的，现在可能出生。刚才你跟我进来。
之前就是
这个
还有2分钟，我讲一个故事，应该时间就很。
让我听讲故事。
说我做不做？
跟你做的人继续做，要听的就继续听。就是我们以前做 tutorial 的时候，不是我们没有一次是完成过我们的 tutorial 去，没有一次。啊，就很长，
我只有中学才能做，
是吗？
到大学没出来。
对，没有完成过。所以我一直在想个问题哦，为什么做一个我完成不到的东西而是？
因为你知道他完成不到，所以你才去做。
对，
挑战你的极限，我觉得我可以完成它。
啊，
最后让我
给学也是，但是就是说，其实最重要的就是那个过程，就是那个过程，你要怎么去overcome，还不错，
真的不要学这个，那个让我觉得那的平均到底在几
？Not 7 and not 5。
OK，time's up。OK，说现在 time's up。如果你做不完没有关系，我们等一下讨论你做到哪里。OK， 等一下我们有答案，然后我们再看和答案差多远。OK，and then 说我要跟你讲的就是虽然你第一次看这个题目的时候，不是好像那种 out of nowhere，就是不知道从哪里来，或者就不知道怎么样去解决。然后我们现在要做的事情就是，我要告诉你怎么去解决它。然后我要告诉你的是，就像一个很难、超级难的事情， 都是有迹可循的。OK 了 ，OK， 所以我现在要告诉你这个迹在哪里，好不好 ？OK， 说请跟我啊，请跟着我啊，不要迷路啊。OK， 跟着我一步一步啊。All right. So first question is find the suprema and the infima. Suprema and infima. This one is the plural. Okay, so what's the answer for A? 1 and 1 over 2. Okay, good. Actually, I posted this solution on Moodle already. 1 and over 2, good. B, eh? B. 1. 一个 not sure. 另外一个是0，为什么是0 ？OK， 我们看一下。OK， 不然我们看一下第一题了。OK， 等一下，这个把它圈起来。还是我们先 check 完答案，我们再一次过看。So who is doing C？ 你觉得是1/5 ？OK， 我们 try 看，等一下。Infima 咩？0 ，OK， good。D。9 and 1 over 9. Okay, good. E? How about E? Is Joshua doing E or not? 0. Okay, so let's discuss E the same or not. Okay, so 第一题 okay, first one. So first, 难切换呢n over n plus 1, where n is n. What's the first thing you want to do? Write down what are the elements in there. For example, when n equals to 1, it is 1 over 2, and then 1 over, 2 over 3, 3 over 4, and so on, 4 over 5. Okay. So now we want to see that this one, the suprema of this is 1. Okay. Few technique we can try. Before proving, not yet prove, we just use something that we already know. Can we rewrite this sequence or not? N over n plus 1. How can we rewrite it? 1 minus 1 over n plus 1. Okay. So in this case here, this one obviously converges to 0, right? Because this 1 over n plus 1 converges to 0 and 1 is the constant sequence. Okay, so from here it's easy to see. How about the infimum? Infimum is the greatest lower bound. Okay, you see that this sequence is increasing, right? So the lowest one is the first term. Okay, so it's 1 over 2. And follow on. Okay, this is just reasoning. We haven't proved yet. So later we will see how to prove these things. Okay, we haven't proved yet. So how about B? B is similar, right? Just that we change the n to all the positive real number. Okay, so in this case here, this rewriting also works, right? It also works. 1 over 1 minus 1 over some positive real number plus 1. Okay, but this real number is still increasing. Okay, I mean not increasing, but you include all the big real numbers in. Okay, and infimum here, how to find? The problem is this infimum here. This infimum here is how to find. Okay, just now this set here is different. Why? Because it is discrete. Okay, but now here is not discrete anymore. Okay, what happened? This n here, what kind of n I can put here? See, say one n I can put here. X. Okay, in this case we say x because we make it a positive real number. What x I can put here? 讲一个 E. Oh, okay, E, sure. So x could be equal to 1, where you get just 1 over 2. What else you can put? Cannot put 0, right? It's positive. strictly greater than 0. Okay. What I can put here? What else? Huh? 0.1 is a very good choice. You know why? Because this will make a little bit of difference. So what happened here? 1 over 1.1 is what? Huh? 0.99999. Okay, 0.99999. So you get something like 0.001. For example, let's say we stop here. Okay. And then you can pick smaller, even smaller, right? Maybe 0.001. Okay, then you can see that this number here getting closer and closer to 0. Okay. Why? 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 Because you are making this denominator here close to 1. Right. So 1 minus something close to 1 is close to 0. Right. This 1 over n plus 1 is close to 1. And then you take the difference between 1. So that value is close to 0. Okay. Okay. So we can actually try and prove this, right? Equals 0. And how about C? How about C? What is C here? Let's see here. 1 over 3n squared plus 5. How about this? What's the soup here? N is what? N is natural number. N is 1, 2, 3, 4, 5. So what's the first term? Yeah. Second term? 1 over 17. And then you can see that this number actually grow, right? So it's decreasing. So which one is the largest one? First one. Okay, so first one is the largest one. So you assume n is start from 0. Okay. Right. Okay, so it's the first term. How about the minimum? Sorry, the infimum. Okay, maybe we don't reach it. So infimum is the smallest one. So you see this one is decreasing, right? Okay. And this n getting larger and larger. Can see or not? Okay, so you are approaching to 0. Okay. D, you need to list out all the possibility, right? All the possibility that n plus m is less than equal to 10. Do you need it? No need? Oh, you mean do like, okay, so you start from this inequality and then you divide m both sides like this, and then so n over m is less than equal to 10 over m minus 1 like that. Is this useful? Yeah. I can use this to find the sum. Yeah. Right. I mean, how you decide what m to put here? Yeah, that's right. So that's right. So you still need to use this condition here, right? So m here could be ranging from yeah, both m and m can be ranged from 1 to 9. Yes, correct. Does it make sense? This one here says that n and m must live in 1 to 9. Does it make sense? Okay. Okay. So the largest number you could get is 10 over 1 minus 1. 对吗？是。So in this class, I want you to focus on making sense 和不合理 ，OK， 而不是跟着抓，只要合理的都解算 ，OK 吗？ 所以我口头上讲的，是不是其实是很重要？我不是讲传哦，你要听，觉得我合理才可以接受。好啊 ，OK。So how about the other way? How about increment 呢？ Divide n on both sides. Wait, let's try your method. What you're trying to do. So how about, okay, what do you want to do? You want to divide n on the inequality? N, so 1 is equals to 10 over n. And then, so you move 1 m over n greater or equal to 10 over n minus 1 like this. Okay, everyone see what he is trying to do or not? Why? What is he trying to do? Huh? Infimum. Why he do like this? Why he divide n instead of m? 哪一个？像驾车啊，你可以跟我讲那边哪一边？左边还是右边嘛，对不对 ？OK。那么 infimum， right？ infimum 你要 bounded below。But 如果你 if you invert the inequality, you will find that n over m is bounded below by what? N over 10 minus n. So you can see that what's the difference between these two? For the second method here, you found the lower bound. For the first method here, you found the upper bound. Okay? Make sense or not? Make sense, ma? Huh? Question. Ask 一听不懂就要问了哦，不然你就会消失了。一听不懂就要问。Okay? 看到吗？ Did you see this inequality change? Okay, so you found some lower bound here. But how do you find the smallest one? Same method. But you see here we got n. Okay, here we got n, correct.
One over n minus 1. You have 1.
I mean, you look through 1 to 10, right? See which one is the smallest one. Okay. So is everyone agree that when n equals to 1, this one is the smallest number? Everyone agree or not? If you put 2, put 3, put 4, put 5, put 6, all of these are greater than 1 over 9. Okay, so let me put like this. This term is greater or equals to 1 over 9. Okay, but 1 over 9 is achievable or not? Is achievable or not? Can I take some n and m to achieve 1 over 9? Can, right? Because I just put n equals to 1, m equals to 9. This is also satisfied 1 plus 9 less than equal to 10. Okay, so this is my infimum. It is the smallest one and I can achieve it. Actually, we call it a minimum. If it is a greatest lower bound and then I can found in the set, it is not just infimum, it is the minimum. If that infimum exists in the set, okay, it's the minimum. Okay. Similarly, you should check that this, what number is this? This 9 here, I can achieve by n over m by choosing n to be 9 and m to be 1. Actually, that supremum is also achievable. It's also the max. So I will write here, this sup here is equal to max d, and then this inc is equal to min d. Okay, because we can achieve it in the set. Okay or not? Because this one is 9 over 1. Okay. Okay, good. So how about E? How to find the maximum and minimum? So learn in calculus, right? Draw a graph. Okay, you can use that method. Why? Because really this is what graph? What graph is this? You factorize it. This is x
times 2 minus x, right? So there are two roots, 0 and 2. Okay, and then this is a negative quadratic. So it's going up or something like this. Okay, but you pick this region here. Sorry, so the region you pick is only here. Okay, x is greater than 0 and less than 2. So from here, where's the maximum minimum? Maximum is in the middle there. Correct or not? Okay, minimum is at the endpoint. What is the minimum here? 0, good, because that's the root, where the root lies. And then how about maximum? How to find maximum? Middle point is 1, right? So if you sub 1 into your function, you get 1. So the increment, the supremum is 1. Okay. E is the maximum of the set or not? Yes, right, because we achieve it. Okay, but is increment the minimum or not? No, right. We don't include the endpoint in. Okay, it is not in the set. Okay, we don't include it. You see, this is strict inequality. We don't include the endpoint. So the 0 point not inside our set. So it's not minimum. Okay. Okay, so we do two proof here. I prepare two proof here. So let's prove for sup A. Okay, let's prove for sup A. Okay, let's prove for sup A. So just now we said that sup A is equals to 1. Okay. So to prove that the supremum of A is equal to 1, what's the definition? What's the definition of sup? I introduce 3 type of definition. Three type of definition. What's the first type? So sup A is a upper bound, which means all x belongs to A, x is smaller or equals to sup A, right? You want to bound from above, you are greater or equals to. But not enough, right? Sup is what? The smallest one. The smallest among the all upper bound. So how to phrase it? So sup A is smaller or equals to all L for all upper bound L. Okay. And then we decided that this is quite hard to check. You want to check for all upper bound. So you say this one is bounded above by 2. So you need to check for what? 1.1, 1.2, 1.3, 1.4, 1.5, 2, 300 million, trillion, billion. How to check so many? Okay, so not very useful, this definition. Okay, so we try to formulate another definition. So what's the second definition we had? Okay, let's make a new space. Let's make a new space here. Okay, so we make a second formulation. Okay, what's the second formulation of upper bound? Seng. What's the second formulation of upper bound? Least upper bound. What's the contrapositive of second statement in the A? What's the contrapositive here? If you are the number that's strictly less than sup A, then you are not A upper bound. Good. Very good. Very good, huh? Okay, so first thing first. let me tell you, when you learn this mathematical analysis, right, you cannot be too rushed. 不要急 because you are just a toddler in this pure maths. You know what is toddler? What's toddler? Yeah, you are just a baby. OK， 不要问我方向，你连走路都不会，我跟你讲什么方向？你会跟你之前我看到你有 post baby 不是？你能不能叫那 baby 现在跟我走去厨房？他连厨房在哪里都不知道啊，你明白吗？说不是有时候啊，不是我不要告诉你方向在哪里，因为我就算告诉你啊，你也不知道是什么来的。OK，so now 我们只能够一步去学吧。OK 吗？说现在要做的事是千万不要放弃，一直学。OK， 有我在陪着。可以吗？OK 好了 ，OK 啊。So yeah，OK， 我们就一步一步慢慢学，一直学，你就会看到了。OK， 很多学生 feedback 给我的课就是来。我上完过后，我就会明白了，或者我上完下一个学期，我知道老师你在做什么，因为你就是要一步一步学的，因为我们很长已经忘记了我们一开始的时候怎么学习，我们现在很喜欢快餐，跟我讲完，讲完了，但是不是这样的，绝对不是这样的，生活绝对不是这样的，对啊，我们要一步一步来。OK， 有时候会给你一些甜饼糖果，不是 always。OK 吗 ？OK，so this one B. So B is the second formulation of least upper bound, and we decided to give the third one. Why? Because we want to be precise. What does it mean by less than? Strictly less than. Remember, last time I told you when A greater than B, what can you do? A minus B is a distance， 有一个距离被你拉出来了，我们叫那个距离epsilon，good， 非常好，这就是这一个课的精华 epsilon。OK，so epsilon， 所以我们怎样把 epsilon 带进来 ？OK， for every epsilon greater than 0，OK。Normally, this epsilon is attached to a real number, positive real number. There exists an A epsilon, okay, inside the set, such that what happened? A epsilon is greater than sub A minus epsilon. Make sense or not? 很乱。First time I see also 蛮乱 ，OK， but this is equivalent to what？ 来，我们做一个 equivalent， OK， sub A is what upper bound 嘛 ，right？ So if sub A minus A epsilon means what? It should be something positive, okay? But this inequality tells you what? This difference here should be less than epsilon, meaning what? A epsilon and sub A is really close. Close. Here, distance, small distance is close. Okay, really close. For every epsilon, I can find someone epsilon close to sub A. Okay, so you see, this thing is algebraic. Okay, algebra is very hard to think. So you need to pull out a real number for yourself. Okay, pull out one real number. So every time in this analysis class, you must bring a ruler. Bring one line. The one line you cannot forget to bring. You know what line is that? One line you need to bring to every analysis class. What line? Then real line. Okay, must bring a real line. Okay. Bring real line. So sub A is somewhere here. Okay, and then A epsilon should be somewhere here, right? So we fix the order like this, getting greater, and then this epsilon is somewhere is the difference in epsilon. Okay, so if I give you a smaller epsilon, let's say epsilon 1, okay, epsilon 1. There should exist one A epsilon 1 here. Okay. No matter how small you get, I can find someone in A. Okay. Then you are the soup. Correct or not? Make sense or not? Okay. So I was going to use this definition to prove it. Okay. Maybe you can use part B to prove it, but I use part C to prove. So meaning for every epsilon, I need to find someone in the set such that it is epsilon close to sub A. Make sense? Okay, so this is my goal here. So let's try this. Let's try this proof here. So we want to prove that sub A is 1. Okay, so write down definition. So after you write down the goal, you need to tell yourself how to go towards the goal. Okay, you cannot say I just want to go Batu Cave. You need to tell me where's the Batu Cave. Right. Okay, and then you plan. You want to take bus. You want to take your own bicycle, or you want to take your own transport, or you want to take commuter. Okay, so write down the definition first. For every epsilon, there exists an A depend on epsilon in A such that A epsilon is greater than sub A minus B. Okay, so this is what we want to do. So how to find it? How to find this A epsilon? Okay, so I don't want to present you the proof first, but let's do some working. Let's do working. Okay, so this is the working we need to do before proving working. So I want to check this is true. Okay, so what do you know about sub A? I guess it is 1. So I put 1 here first. Okay. How about A epsilon? Do you know anything about this A epsilon or not? There's one thing you know about this A epsilon. What's that thing? Your A epsilon is in your set A. But do you know your set or not? So A looks like this. N over N plus 1, where N is natural number. Every A have to look like this. Does it make sense? Okay. So your A is something N over N plus 1. Okay. You want to make this true. Find. So your problem is find N such that this is true. How to find? How to find? How to find N such that this is true? Given epsilon. How to find? How to find? For every epsilon, you need to find such N is true. Given 是什么意思？给定一个 ，OK？ 那我们定一个咯。现在说 epsilon 要大于0 ，what choice you can make here? Sure, E. Okay, let's pick epsilon equals to 1. Be really looking down. So let's say we pick epsilon equals to 1. So in this case here, N over N plus 1, right? 0, sorry, E 1. So N over N plus 1 greater than 0, meaning you need to pick what N here. N can pick what? To work. 1 work. 2 also work. 3 also work. 4 also work. Actually, everything also work. Okay, so we just pick any one. N equals to 1. Okay. Since epsilon would be greater than 0, right? You can pick other epsilon. What kind of epsilon we can take? What other epsilon? I don't want anything greater than 1. One over 2, good. So 1 over 2. So what N will work? Greater than 1 over 2. 1 minus 1 over 2. What N can work here? 2, 3, 4. 2, 3, 4. Sure. So n equals to 2 is what? 2 over 3. 2 over 3 greater than 1 over 2, right? Okay. But in general, how to find? I want a general. For every epsilon, you want to find me an n. Is there a general way to find or not? How do you find just now? Do you just test number? Test, huh? Do you just by testing? How to find 1? Yeah, how do you find for epsilon 1? How do you find this n equals to 1? Do you do by testing? By try and error? Try and error you? Also try and error. But we can find a formula to find it, right? You know how to find it? Don't know? Think again. If you want n over n plus 1 is greater than 0, what does it mean? You can multiply n plus 1 on both sides, which means you want to find n greater than 0. So n equals to 1 word, because 1 greater than 0. Bottom here, same case. This is true if and only if n is greater than half n plus half, which means what? 1 over n is greater than 1/2. Implies that n is greater than 1. That's why Jack just now said n equals to 2, 3, 4. Because I prove it. Understand or not? Okay. So in general, how do you find for general epsilon? How do you find for general epsilon? Huh? What do you do? How do you find for general epsilon? 1 minus epsilon. How do you find for general epsilon? This implies what? It's greater than minus epsilon times n plus 1. Okay. And then what? Open the bracket. N plus 1 minus epsilon. Okay. I think we just keep n on one side and then 1 minus 1 epsilon one side. Okay. And then I can move the n together, right? I can group the n together. If I group the n together, what do I get? Epsilon n greater than 1 plus 1 minus epsilon. Correct or not? Everyone follow? Can follow? I just minus subtract. Okay. And then we prove that we can do this by using order law, order axiom. And then next. N have to be greater than 1 minus epsilon over epsilon. Then I can find the n that works. Okay. Does it make sense? Okay. Okay. So meaning what? I need to pick my capital N epsilon to be greater than this guy here. Only that all the terms after it is greater than the epsilon, the 1 minus epsilon that we want to check. Okay. So meaning what? Meaning we need to find n epsilon to be greater than 1 over epsilon minus 1. Okay. Okay. So by doing that, okay, by doing this, if we choose this n epsilon here, okay, and then we let a epsilon to be n epsilon over n epsilon plus 1, what do we get? Okay, we get the difference, okay, the sup minus the a epsilon to be less than to be less than epsilon. Does it make sense? Okay or no? Any question? Any question here? Any question? Any question? Okay. Okay or not? So you see, the way we choose this n epsilon, right, is exactly we want this to work. Okay, so you need to make sure that the way you choose n epsilon, you make the final inequality here works. Okay, so you need to play around, shift around this n epsilon, the inequality involves n epsilon to get this final thing. Okay, does it make sense or not? Make sense or not? Okay. Yeah, so please, if it is make sense now, right? Okay, once you go back, right, make sure you go back and do it. Write down yourself, okay, because you will forget one. Okay, I also forget, so I need to write down. I think I also know Wi-Fi. Wi-Fi gone. Let me try that. Is it really no Wi-Fi? Any question or not before we rejoin? A question or not? This one is very important because if you don't get this part right, most probably the thing behind you won't get it. Must get this part first. Any question you should ask? Okay. Yes. More complicated? Okay. Okay, sure. You mean more complicated sequence? Can? Sure, no problem. Wait. Any hotspot? Does hotspot work here? Work. Right. So we finish this and then we will take a break. Can or not? Let's finish it and then we'll take a break. Okay, good. So we come back here. So in general, for harder AN, right? Let's say for this guy here. Let's say for this guy. Okay, Joshua. Let's say for this guy here. We want to show suit for this guy. So what's the suit for this guy? 1/8. Okay. So this guy is 1/3n squared plus 5. Okay. You want to show that this, so the suit is 1 minus this guy here is less than epsilon. So what n to pick here? Correct or not? This is our question. So how to pick this n here? Okay. So we want to pick n such that this inequality works. So how do we do this? So we move around. So how to move around? So first we will get 1 minus epsilon is less than less than 1 over 3n squared plus 5, right? And then this one is true if and only if 3n squared plus 5 is greater than 1 over epsilon minus 1, right? Sorry, 1 minus epsilon. Okay, and then we want to find n, so we need to move everything away. So n squared is 1 over 1 epsilon minus 5 over 3. Okay, of everything over 3, like that. So you want to make sure that your n square is greater than this number. So you need to find n such that n is greater than square root of the whole thing here. Make sense? 1 over 1 minus epsilon minus 5 over 3. Of course, you try and simplify it. Okay, but this is the idea. Okay or not? But why you can find this n? Tell me, why this n exists? Why this n exists? Huh? This epsilon fixed, right? So this whole thing here is a real number. How to find an n that's greater to be some real number? Why this n exists? Archimedean property. Okay, so it's by Archimedean. You can find this n. Okay, does it make sense or not? So in the end, to the very end, the only really thing you need to check is this guy here. This inequality here you need to check. Once you check this, it will tell you what term to pick. Okay, make sense? Yeah, it will tell you what things to pick. Okay, should we take a break or we discuss one more and then we break? One more, then we take a break. Okay, one more is, so I do one example on soup, one example on inf. Okay, we'll do one example on inf. So let's show that inf of e is 0. So what's e here? So let me copy the e down. So e is equals to 2x. Okay. So we say that inf e is 0. So we're not prove it. So this case here, I will pick the definition 2, okay, to do a variety. I'll use definition 2. So to use definition 2, what do? I show that this number is a lower bound first. And then everything that is greater than this number is not a lower bound. It's like opposite of upper bound, but it's a, yeah. So I use this definition 2, version 2 to prove this. So is it easy to see that 0 is a lower bound or not? To say that 0 is a lower bound means what? This set of number is always greater or equal to 0 when x is in between 0 and 2. Okay? But this is true, right? So in the high school, right, how you check this inequality? Yeah? You find x such that x times 2x is greater or equal to 0. How do you find it? At least for me, my teacher teach me like that. Also, you draw this quadratic, right? Okay, and then you intersect, right? Got 0, got 2, right? Greater or equal to 0 is where? The top, the top is here. And then here, the x is in between 0 and 2. But for like our university level, right? How we check? We check. If this number is greater or equal to 0, means what? This is a product of two numbers, right? Meaning the two number is either both positive or both negative. Okay. Right. So if you pick x to be negative, can or not? Then 2 minus x is always positive. So x cannot be negative, rule out already. Okay. Then now you need to make sure that both of them is positive. So how to make sure both of them is positive? If x is positive, then s is positive. Okay. But how to make sure 2 minus x is positive? Your s has to be in between 0 and 2. Okay. So exactly this is what you have here. But you don't have the point 0 and 2. But still, you still have the result. The product is greater or equal to 0. Okay. Can or not? If you want to write it out. Okay. If you want to write it out. So this part here, I comment here. Product of positive number is positive. Okay, and product of negative. Okay, product of two positive number and two negative number is positive. Okay. Okay, good. Next, if you don't believe, you can prove from the order axiom. Okay, next part is to show that any number is greater than 0 is not a lower bound. Okay, meaning what? Meaning if you have this distance, right? Again, I have x greater than 0. So please pull out your ruler. Okay, your line. Pull out your real line. Okay, x greater than 0. So x is on this side. Okay, so there's an epsilon here. So if you say that x greater than 0 is not a lower bound of E, means what? Means what? If this guy is not a lower bound for E, so E is somewhere maybe like here. It's not a lower bound means what? You cannot bound it. So meaning what? You cannot bound from below. For every A in A have to be greater or equal to X, right? If it is not a lower bound, meaning there's someone that is even smaller than X. So there's some E here. Okay, so you want to find some E in between 0 and X. Okay, to prove that X is not a lower bound of E. Okay, so how to do this? So to do this, I split into two cases. Okay, I split into two cases. Why? So let's draw this picture. Okay, our graph is look like this. Where is the E? E is on the X axis or the Y axis? Yeah, the point of E. You see this E here is in X axis or Y axis. This point here, Y axis. Okay, it's on the Y axis. All these point here. Okay, and then just now we check the highest point is what? Okay. So X greater than 0, what happened? X could be everything to the top here. Okay, can be everything. So if X is greater than 1, I just simply take this one here. It's in between. So okay, so let me zoom in. So if X greater than 0, I split into two cases. So split into X greater than 1. Okay, we move here. So let's draw it again. Like this. Okay. So we have 1 at the top here. And then this graph here is y equals to 2x minus x squared. Okay. So if x greater than 0, what happened? So we split into two cases. So first cases is x greater or equals to 1, greater than 1. And then the second case is x less than equal to 1 and greater than 0. Okay, does everyone agree? I can split into these two cases? Can or not? But why I do this? Why I do this? Remember what we want to do. Find E in E such that 0 is less than E and less than X. This is what we want to do. If X is greater than 1, meaning what? It lies above here. So what's the point in E that can fit into this inequality here? Yeah, I can pick anything on the graph here, 0 to 1. Okay, in particular, I just pick 1. Okay, but if my X is in between here? Leh? Can you find a point in between x and 0 or not? Can or not? Huh? From the graph can. Okay, but how do you do it rigorously? How do you find if, like, for example, if I give you this maybe x1 here, okay, how do you find this e? Sure, x over 2, right? This point is x over 2, but you need to tell me that this is a point that is achievable by some point on the graph, right? So you need to find this x. Is this x lies between 0 or 2? And you need to find. Okay, you need to find. So let's see it. Let's try. Okay. So here. So to see the each x greater than 0 is not a lower bound of E, we need to find an element in E such that E is in between 0 and x. So it's split into two cases. Okay, just now we discussed. S greater than 1 and S is less than equal to 1 and greater than 0. So if x equal to 1, how do we find my E? I just find my E to be 1. Why? Because 1 can be written as the y value, the y point. How to write as a y point? 2x minus x squared. What x you need to pick to equal to 1? X equal to 1. Okay, because 1 is in between the 2. So but how about x is less than equal to 1 and 0? How do you find it? So like Ethan said, I didn't pick x over 2, but I picked x over 4 because I want to make my pre-image looks nicer. Okay, so you need to argue how you can find the pre-image. But how to find the pre-image? So let's say let's say this is x over 2, right? Okay. So what's our goal? We want to show we want to get x over 4 in E. Okay. What does it mean by x over 4 in E? You can write x over 4 to be equals to 2y minus y squared for some y in the open interval from 0 to 2. Correct or not? Okay. So how to solve this quadratic equation? So you use quadratic formula, right? How to use quadratic formula here? Y equals to plus minus, sorry, okay, minus, right, minus b square, minus b, okay, what's b here? Should be minus 2, right? Okay, so become plus 2. Plus minus square root b square minus 4. A is 1. C is what? X over 4. Then the reason I pick x over 4 here because my a square got 4. I want to get rid of it. If you pick x over 2 also can, but you just leave out x over 2 here. Okay. Over 2a. So 2a, a is 1, so it's over 2. Okay, so that's how I get this point here. Okay. So you can pick plus 1 or you can pick the minus 1. So I pick the plus 1. And then I need to argue that why this 0 point I pick is in between 0 and 2. Okay, I need to argue about this. Okay, how do I argue about this? What do I know? I just really know that x is less than equals to 1 and greater than 0. I can only start from here. And then start from here, I try and prove that. So here, and then I prove that 2 plus square root 4 minus x over 2 is less than 2 and greater than 0. You believe me or not? Can believe me or not? Only from this part, so this is the claim. Only from this part, I can get the whole thing is in between 0 and 2. Can believe me or not? Try. Yes, you must try. Okay, don't believe me. Try. Okay, you must try. So let's try. Okay, so let's get this statement and then we prove it. Let's try. Let's try. So you see, although the proof is very short, there's quite a lot of things going on. So that's why a lot of people are confused what's happening. So how to prove it? So you need to get the 4 minus x out first, right? Slowly build this number here. So in particular, you need to get minus x first. So if I get minus x means what? I will get 0 greater than minus x greater or equals to minus 1. Okay. And then I can plus 4 to both sides, all the sides. So I get 4 greater than 4 minus x greater or equals to 3. And then what else you need? You need square root. So I get 2 greater than square root 4 minus x greater or equals to square root 3. Okay, and then what else? Plus 2. So plus 2 on both sides, all the sides, not both sides, 3 sides. And then divide by 2. Okay, so one side is good already. Less than 2. How about the other side? Square root 3 is greater than 0. Plus 2 still greater than 0. Divide by 2 still greater than 0. So everything here should be greater than 0. So I get this inequality here. Make sense? Okay or not? Okay. Okay. So this proves that what? The pre-image here is in the right range. Okay, it's in the right range. Okay, given x in the range of in the range of 0 to 1. Okay. Okay. So there are quite a lot of things going on. So you need to check. Okay, although my proof is seemingly quite short, but you need to really check everything what I say here. Okay or not? OK， 再分享一个适应，不要气馁的字。我以前也是很笨，为什么我讲我笨？你看这个 proof 很短，我就讲你笨，我笨罢了，我笨罢了。我就跟你讲，我也是很笨，所以你就不用怕了。OK 吗 ？Yeah， 所以我很怕，是不是我笨？我很笨，我那么笨。OK， 我为什么笨？以前呢，我看这个跟你们一样年纪的时候我也是看不懂。为什么我看不懂呢？你看我刚才做了多少事情？这一句话里面藏了很多东西，你知道吗？你要把它出来，你要去 prove 它。一个加一个加哇。Yes， 一个加一个加哇，对。你要每一句话都 prove 出来，就是说，假设我有这个，我们 consider 这个，为什么 consider 这个？你就要 expand 它 check 哦，为什么它真的是 S over 4？然后你就想哦，为什么我找得到这个东西？其实就是 quadratic formula 罢了嘛。OK，and then 我要 prove that 它是 in E。OK，to prove that it is in E，this pre-image here need to satisfy this inequality here。把这边讲来，不是天上掉下来哦，是从这里来。OK 吗？所以 you need to check 哦，很多东西要 check， 有时候不是笨啊，是你不了解它后面在做。OK，so one thing is to like understand what's the mechanism。OK， 比如说我们政府这么这样烂，你要去了解它到底后面藏了什么问题在里面。那问题如果丢在你身上，你能解决吗？不能。所以咯，所以我们现在还是这样哦。如果你能够解决，我们薪水就起了哦。对啊，对不对？对，是不是？是。好，各位好。OK， 是不是？OK， 所以就是呀，所以每一句话你都要 understand， 要 understand 每一句话去 check 它，一步一步 check。OK， 只有2条路好走的，如果你 check 下去，只有2条路，你知道什么路吗？ 我们课已经开宗明义讲了 ，statement 只有 true or false， 你只会拿到对或错罢了。如果你 prove 到这个东西是错的，人它可能就是错了 ，OK 吗？你明白吗？你只有2条路好走的，在数学，不是对就是错的 ，OK？ 啊，你不可以讲我不知道在哪里，这样就是你还没有走罢了。你一定要走，在数学里面 ，OK 了。You must walk the talk.
Yes, try your best.
Try your best. OK， 我们有 OK， 讲完最后一个，我们 take a break 啊。
Yes.
数学最重要的一个点，
理解。
好，这个是其中一个。还有一个 make your hand dirty， 什么意思？把手弄肮脏，什么意思？你吃饭的时候，如果用手拿，是不是很肮脏？
是。
所以你要动手去吃，动手去做，手一定要拿下去做，手笔一定要拿起来。OK， 不能够用想的、听的而已，没有用。
对。
一定要写下去。
亲身经历。
Yes。OK 了，没有 hand dirty， 非常好啊。
必须。
所以一定要做，一定要做。OK， 我给了很多题目啊，那些书啊，书还有答案啊。OK， 做一定要做。OK， 如果你没有读 lecture note， 如果你不做的话，你肯定是不知道的。OK， 肯定会不知道，你不能够听罢了。好，一定要做，一定要做。喂，OK 啊。All right, so let's take a break. Break until 12:30啦，12:30 too long 已经要完了，差不多要结束了。OK。
没有。这我可以去掉。
这3个上来。
唱。
看怎么办？ 不能是大学，
而且做这个题啊，讲到讲到打球，
就是标准的。这个也是。
本来绿带我不发给，所以我可以做完。
还有服务，要
那就好来，
可以。
加油！
还有3分钟呢。
22、32分，50分钟。巴迪，我就很傻，不要理我。
唱啊！
我不要唱哎。
做那个
做的全部是
你的
错的。
quality 啊，对，找 for 它不等于的情况下，因为我这里只写它，
这位同学的才。
那里就写那个等于那个。
我们不要大于，我们不要等于，是要我们需要10个就好了。对啊，
我要讲这个东西大于它，然后找出 n
哦
n 大于2，这种才会大于
，OK
这种
OK，没有问题。
为什么我可以写 n 大于2？因为我上面这里写，我这里到这样子，现在你们
哎，对，没有错，这个我知道。
这个n square，然后这里选大于，然后选 maximum 对吧？我觉得等于2，这里我要考虑，如果它等于它的话，
所以等于什么？
就这里我是否
哦，OK，
这个全部
对
n square，如果否等于的话 ，n 应该会是多少？然后再拿这个等于的 n 去跟如果大于它的 n 的2去比，总共还是2，所以我只要选大于2，这种就一定是
对
大于它，不
合
可
理，
这样子就可以。
合理啊，合理。
那其实如果做这个的话，其实如果我写这个的话，我这样写的话，你会写这个东西。我是小一个，问题还有小，所以对，
直接小于，
那我可能不用做这个，
不用太仔细哦，这样讲哦，看你的仔细程度到多少嘛。
OK，
呀，
就这样，
是这样意思。你 as long as 你要选你的 answer， 你会过就对。
可以。
但是当然我们可以有更简洁啦，慢一点再修改。
你刚叫我做那个。
对，你先跟着这个 principle 去做，然后之后我们会推出更简洁一点的。
那如果比如说你分享回来就可以看这个。
好吗？我们先开始啊。还有4个小时。
不要上课了。
Hello, testing. Okay. Should we start? Let's start new stuff. We don't continue. But the solution is already posted. Okay, before the last weekend, Friday. So I spent this 1 hour, right? Actually, is out of budget. Okay, we don't have budget anymore actually. So sometimes we need to be a bit quicker. Okay, so let's see how we give and take. Okay, we adjust the tempos. Let's say, if we cannot finish syllabus on time, maybe we make extra class. You guys okay or not? Are you guys okay if we make an extra class? But that extra class is not forcing you to come, but I will make a record. If you cannot make it, then no need to make it. Then you can watch recording. Let's say because this is the first time I taught this course, so I'm not sure I will out of time or not. Okay. Yeah, start now. Start saying. Yeah, let's start. Let's start new stuff. What's the last theorem we introduced last time? Yeah, Bolzano-Weierstrass theorem. So what does the Bolzano-Weierstrass theorem say? Huh? Say? Where's the sequence? Where to find the sequence? Read the statement. What's the statement say? Okay. Okay. So how do you imagine sequence? Remember? You remember sequence as a function, right? As a function. Okay. So you have like A1, A2, A3, A4, A5, A6, A7, A8, A9, right? So the theorem says what? If all your sequence, is in the bounded closed interval, you can find a convergent subsequence. Okay, you can find a convergent subsequence. You can see that this sequence here doesn't converge, right? Why? Why this sequence doesn't converge? Hey, why got ping pong sound one? Bruh. Infinity, bruh. Mountain. Okay, mountain. All right. So there's no one point that you can find all the point behind n is there doesn't exist an n such that there doesn't exist a capital N such that all the term behind the capital N it is close to a number. Okay. But the theorem says what? You can find a subsequence that converge. Okay. Can you find a subsequence that converge or not? What's the last thing we did last time? How to prove it? We use the pigeonhole principle. Okay. How do we use the pigeonhole principle? We say that we can take this open interval and then we halve it. Okay. We halve it and then we choose one of the interval. Okay. That has infinite terms. We can do this because our sequence has infinitely many terms. Okay. Let's say we pick one of them. Let's say we halve it here. Okay. Let's say we halve it. So we have it here. So C plus D over 2 here. Okay, we have it. So let's do this point on this. And then we pick one of them. Okay, we pick C1, D1 here, right? There are infinitely many terms here. Okay, and then what's the next thing we do? We halve it again. Right, we halve it again. Okay, we take the half of this graph again. Okay. And then we pick the interval with infinitely many terms again. Okay, let's say we pick here C2 and D2 here. Okay. How do we make the sequence last time? From the first one, okay, from the first interval, which term I pick as my first term of subsequence? We pick the least one. Okay, we pick the least one. We pick this one. Okay, we pick this guy as our B1. Okay. Let's say I pick another interval here. Okay, let's say I pick another interval here. So we pick the least one again. So we pick which one? What's the term within this interval here? What are the terms within this interval? Where's my B2? C plus D over 2. Repeat this again as my B2. Okay. And then I halve it again. Okay, I halve again. And then I pick left or right. Okay. If I pick the lower one, I pick this one as my B3. Okay, and so on. Then what can you see here? In this case here, I produce a constant sequence, which is convergent. Okay. So let me write this theorem here. So every sequence AN contained in a closed bounded interval AB, okay, has a convergent subsequence. Okay, so this is what we did last time, convergent subsequence Bn. Okay, and it converges, which converges, converging to some point in the interval AB, some point in AB. Okay or not? Okay, you can see that this convergent subsequence here converge to some point in CD. Make sense? Okay. Okay. Can or not? Can. Okay. So this picture here is the idea of this idea of this theorem. Okay. I'll present you another proof. Okay, I present you another proof. Because this proof here will produce a different convergence sequence. Okay. Let me produce another proof. Proof version 2. Okay. Okay. So before we prove it, we want to define a point. Okay. So we define a number n, okay, to be a vista point. Do you know what's a vista? Vista is view. Have you heard hasta la vista? You know hasta la vista? No. No one heard about hasta la vista. Oh, okay. It's a Spanish about goodbye. I think I heard it from cartoon or some movie. Hasta la vista. So see you later. Okay, vista is view. So why we call it a view? So it's a vista point of sequence AN if AM less than equals to AN for all M greater or equals to N. What does this mean? This means what? This means what? The term AN here, everything behind it is smaller or equal to it. So you can see that you are like a observation deck, like a 观望台, you know. You can stand on here and then see all the terms. So that's why we call it a vista point. Okay. Peak, huh? Okay, yeah, some material call it a peak. Okay, also makes sense. Okay, so it's like you can see the view from the top, okay, or the peak. Yeah. Okay, vista point. Okay, we're gonna use this to prove it. Okay, to prove our theorem here. So how to prove it? So there are two cases. Okay, so there are two cases. One, there are infinitely many vista points. One, our AN have infinitely many vista points. Two, what do we have? There are only finitely many vista points. Okay, can you imagine or not? If you have infinitely many vista, test one, how does the sequence looks like? 有无限个观望台. So how does the sequence looks like? Huh? What mean a straight line? Straight line like this, straight line like this. You can have straight line like that. What else? What else? You want to try? Mountain, good. So maybe like this, come out a bit, go down a bit, come out a bit, go down a bit. Okay, you can do that. Okay. And how about finitely many? What happened if there are only finitely many? Finitely many, what kind of sequence can exist? There's only finitely many of them. Almost non-increasing, right? Some part, the tail have to be start non-increasing. So maybe you have something like this, go down a bit, maybe go out a bit. But in the end, you should always go up. Or you should always, can you always go down? No? Cannot. Okay, you go down, cannot. Because going down is less than or equal to. Yeah. Okay, you should always go up. Okay, so at the top here, who are the Vista point? So let us point out the Vista point here. So the green one are all Vista point. These are Vista point. And then this guy should be also a Vista point. Right? This guy is a Vista point. Okay. Then this guy is a Vista point. This guy Vista point, Vista point, Vista point. Does it make sense? This 2 is not a Vista point because there's the next term which is greater than it. So it's not. Okay. And then here, Vista point, who is the Vista point? So let's say we don't want to make it so high, right? So let's don't make it so high. Let's make it converge to somewhere. Maybe converge to somewhere like this. Okay, then we can pick up this guy as a Vista point. Okay, so we break into these two cases. How are we going to prove it? So let's see. Let's see how we're going to prove this. So if you have infinitely many Vista points, right, can you do something or not? Can you produce subsequence or not? Can you produce subsequence here? What kind of subsequence you can produce? I mean, either constant, either. I mean, how you produce, how you pick, You haven't tell me how to pick. So if I give you a sequence, how you pick a subsequence? Okay. You cannot just pick A1, 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 A1. That's not the subsequence, right? Last time we decided it's an increasing function. Okay. So how we pick? So a very natural choice here is just pick the Vista point. Just pick the Vista point. Because you have infinitely many of them, right? A natural choice here would be just pick the this is sequence of all the Vista point. Okay. So what's special about this Vista point here? This Vista point, what's special about this point here? Yeah, getting smaller and smaller and smaller, or it can stay constant. Meaning what? This term, this Bn here is non-increasing. Okay, why? Because we require that Bn plus 1 is right. Let me see. So Bn plus 1 is less than equals to Bn. Okay. Right. To be a Vista point. Okay. But at the same time, you know that this Bn is that live in a close bounded interval. Meaning what? These terms are what? It live inside a open interval. So open interval is from what did we put? A to B. Okay. from A to B, meaning it is bounded below by A. So it is non-increasing and it is bounded below, means what? It is a monotone convergence sequence, okay? It is bounded. So it is monotone, it is bounded below, every bounded monotone sequence converges, okay, by MCT Bn converges. Okay, so this is the subsequence. This is the convergent subsequence we want. Okay, but how about there are finitely many AN? How do we get a convergent sequence here? Like in this case here, how you find the convergent subsequence here? Which sequence will converge? Which subsequence will converge? Remember, we are bounded by something, A and B. So if this part here keep increasing, right, it will finally reach B. Okay. So try and pick up this increasing sequence here. So how do we call this increasing sequence? Okay, how do we construct this increasing sequence? So let's argue like this. Since there are finitely many Vista point AN, that means what? There exists a number, let's call it J1, such that for all the terms behind J1, N is not a Vista point. Of AN, correct or not? Okay, this one point is not the Vista point. And then, meaning what? If this point is not a Vista point, right? Okay, I can try and find someone that's greater than this point here. Because if this is a Vista point, then everything must be less than it. Okay, so if it is not a Vista point, then I can find someone larger. If this point is not a Vista point again, I can find someone larger. I can find someone larger. Keep going up. Okay, increasing. Okay, but this increasing is good. Why? Because you are bounded above. So you are monotone bounded above sequence, meaning the sequence converge. Okay or not? Does it make sense? Okay. Okay. I'll write down the full argument in the lecture notes, but you need to understand what the proof says. Right? This is what we discussed now. Does it make sense or not? If you have a Vista, if you don't have a Vista point, okay, every point behind it should be larger than it. If you are not a Vista point, meaning what? There exists some point behind you which is greater than you. Not everyone, but there exists someone. Okay, and if that point is not a Vista point, you can go again, go higher. Why you can do this? Because there are really only finitely many Vista points. Okay, you cannot say, oh, this point is not, next point is not, the other point is not. Cannot be infinitely Vista point here. Okay, so you confirm will reach some Vista point. When you reach, so you will confirm reach some point which is not a Vista point. Okay, when you reach that, you can find someone that's greater than you. Okay, and then if there's not a Vista point, then you go again. Then you can create these increasing sequence here. If you create an increasing subsequence and it's bounded above, then by monotone convergence sequence, it converges. Yes. Yes. You need to define. Yes. 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 You define it inductively. Okay or no? We don't have time to write down the proof, but do you get the idea? Okay, once you get the idea, I will write down the proof and then you read whether it match what I say or not. Does it make sense? Okay. Yes. Okay. Why? How is it? Yes. Okay. Okay, so before we finish, let's come back to this example. And then if we use Vista point to pick out the sequence, you know which sequence you will pick up. If we use Vista point to pick out a subsequence here. Where's the Vista point here? This guy, and this guy. Okay, so you pick a different convergent subsequence here in this two proof. Okay, so if you use the Vista proof here, you will pick up the top convergent sequence. But if you use the pigeonhole principle to prove it, we will either take out the last one, the middle one, or the top one, either of them. Okay. But if it is a Vista point proof, we will only pick up the top convergent sequence. So that's why I want to introduce this two version of proof, because I want to give you an idea that this proof might do different stuff on different example. Okay, but we still get the same statement. Okay, that is every sequence in a closed bounded interval has a convergent subsequence. Okay, but this convergent subsequence can be anything that converge. Any subsequence. Okay, no? Okay, I think you guys think about the assignment, right? So if you have problem tonight, if I got time, then I will reply to you. Okay? You got car? Okay. You guys tomorrow.